So in this video, we're going to look at Pluto and the minor planets. And if you're following along in OpenStax, it's chapter 12. So let's talk about the discovery of Pluto. Pluto is very, very far away. So it took a while, and it was the last one discovered. And we kind of had some suspicion that it might be there, because the planet Uranus had deviations in its orbit, which was suggesting that there was some other source of gravity, something else causing a force of gravity in the outer solar system. It was discovered by Clyde Tombaugh, and he worked at the same observatory as Percival Lowell, who had just died. And in fact, there's some suspicion that the name Pluto was chosen because the first letters in Percival Lowell's name are P and L. But also Pluto was the Roman god of the underworld, which was thought to be this really dark place where some souls went after death. So they could kind of see Pluto being way out in the darkness of the outer solar system. Now, how did they discover it? What they looked for was, and I think they have the arrows here at the dot, they found that this dot here that they were looking at was moving, and it was moving too much to be a distant star. Now it's called a dwarf planet. And for a while there was the term minor planet, but I believe the currently accepted one is the dwarf planet. It's interesting in that it's only 60% as large as our moon. It's smaller than our moon. Yet we call it a planet, and we don't call our moon a planet, we call it a moon. Now it has a large moon itself called Charon. Charon was the boatman in Greek mythology who would take the souls over to the underworld. And it's pretty large as well. You can't see it here in the picture, so some even suggest maybe we'd be better off calling it a double world, because Pluto and Charon kind of orbit around each other. It's a rocky, icy world, a lot like Jupiter's moons. Now, you may remember that the inner planets, like Mercury, Venus, Earth, and Mars, are rocky. And then we have the giant or the gas planets. Jupiter, Saturn, Uranus, and Neptune. And now out here we have this tiny little thing called Pluto, which is also rocky. So it's not really fitting in with Jupiter, Saturn, Uranus, and Neptune. It's not fitting in with the gas giants. And it's also unique in that it's actually sometimes closer in its orbit than Neptune. And I'm going to show you that on the next picture. So you can see in this nice animated GIF here how there's Pluto. That's the purple. And Neptune is the blue here. Its orbit. And of course the sun is at the center. And sometimes Pluto crosses inside. So even in that way, it's not behaving the way a planet that we think should be, because none of the other planets cross inside the orbit of other ones. So we have this question, well, is Pluto a planet? And the answer is yes, it's a dwarf or minor planet. But we don't say it's an official large planet. Some people get upset about the change in the names, but it's still there. It's the same as it's always been. It's just a classification difference. So why don't we say that Pluto is a regular old planet? We would say there's 8 planets in the solar system. I grew up learning 9, but there's actually only 8 because Pluto's a dwarf planet. It does not clear its own orbit of debris. So what does that mean? A large planet like Jupiter, as it goes around the sun, has enough gravity that it will either attract any other rocky bodies as a moon, or those rocky bodies will just get attracted and crash into Jupiter. And the same thing is true of Earth and Mars and all these other planets. And they cleared their orbit of any basically space rocks or space junk many, many millions of years ago. It's just that Pluto isn't large enough. And what we started to discover fairly recently is that there are many other trans-Neptunian objects. So if here's Neptune, and here's Pluto. Now, if Pluto was out there all by itself, maybe we'd say, okay, it's a little different, but we'll still call it a planet. And that's what we did for many, many years. But now we start to find a whole bunch of other worlds out there. And these are what we call trans-Neptunian. Or this is sometimes called the Kuiper Belt. I know it's spelled Kuiper Belt or that something, but it's called the Kuiper Belt. And what we think is a lot of these little objects out there are kind of the remnants of the early solar system, things that weren't quite big enough to form major planets. So here's some of the largest known ones. So here's Pluto, and you can see how big its moon Charon is, and it has a few other little tiny moons, just things that it's attracted over the years. Styx and Nix and Kerberos and Hydra and all these kind of their monsters from Greek mythology. But out there also is another trans-Neptunian object, or another dwarf planet called Eris, and it has a pretty big moon as well. And if you look, Eris is very similar in size to Pluto. So if we call Pluto a planet, we'd probably have to call Eris. And then there's another one. Now, I don't know if this has to do with the way the picture is. It's not egg-shaped, but Haumea, Makemake, Gong, Quar, they've started to get a little beyond the Greek mythology and starting to name some of them for different, like I think Haumea is from Hawaiian mythology, and using other mythologies to name these. So there's a whole bunch of them that are out there past Neptune. And they just have the Earth and the Moon here kind of to give you an idea of scale. They're all smaller than our Moon. So the scientists were in a quandary. They would either have to say they're all planets, or maybe they're their own classification, and that's what they went with, a dwarf or a minor planet. Now, some other things that are in the solar system, since we're rounding out our tour of the solar system, are asteroids. And as far as we know, there are nearly 1 million in our solar system. And we're pretty sure these are fragments from the early solar system. Now, let's talk about where they are. There's the Sun. Between Mars and Jupiter is where most of them are, the asteroid belt. But there are other ones. There are asteroids even between us and the Sun. And there's some that are much further out, the Trojan and the Greek asteroids that are all the way out by Jupiter. And you notice how they kind of fall into Jupiter's orbit here, these two sets of asteroids. Now, but most of them are in between Mars and Jupiter, and they may be a planet that never formed. That's one way of thinking about it, that there was enough stuff there that perhaps there could have been another planet in that range, but it didn't form. Now, a question might be, well, can you fly through an asteroid belt? Because we've all seen the movies like in Star Wars where the spaceship is trying to get through the asteroid belt and they're zinging by and, oh, is it going to crash into the asteroid? And it's a lot of fun and it's very suspenseful. But at least in terms of our solar system, it's not true. As far as we know, the distance between each asteroid is about 2.5 times the distance between the Earth and the Sun, or Earth and the Moon, between the Earth and the Moon. So that if you were flying a spaceship and you saw 2 asteroids, no problem. You'd be able to fly through them, no problem. They're not close enough that we have to worry about crashing into them. They're just not dense enough. Now, there's 3 main types, and the letter tells you the type. S-type are silicate, mostly made of quartz and sand, and they're the ones that are closer to the sun. And they're very reflective, so they're very light-looking. The C-type, or the carbonaceous, meaning they have a lot of carbon in them, are further away, and they're dark. Think about how black charcoal is, where charcoal is almost all carbon, especially if you've ever gotten any on your fingers. And that's what we think the carbonaceous asteroids are made out of. Meteorites are also characterized this way. We have carbonaceous meteorites. And then there's the M-type, which are metallic, which suggests maybe they're the core of a planet that tried to form or did form and maybe didn't last very long. And there's even some question there's a lot of metal in the asteroid belt. Would we be able in the future to send either robots or people out there to mine all that metal that's out in the asteroid belt. But we can travel through it safely, no problems. Now, two really big, or probably the biggest, most famous of the asteroids, one is called Vesta and one is called Ceres. And they're in this asteroid belt. Let's even put it on the picture here. And I'm not putting it, I don't know exactly where they are here. I'd have to look that up. It doesn't matter. But they're in the asteroid belt. And they're really big. Now, Vesta, you can see, is kind of, like I said, potato-shaped. It's not very regularly shaped, and it has impact craters. But Ceres, boy, that almost looks like a small planet. And I guess under some classifications, they'll call Ceres a dwarf planet, or it definitely used to be called a minor planet. And we can get great pictures of them from, I believe these are from Hubble Space Telescope, but they can see them from Earth as well. So those are two of the largest of the asteroids that are out in the asteroid belt.